Luckily, we've already been working with cross products for a little bit now. The part 2 of the 5.2 notes is regarding still proportions, but specifically the cross product of proportions and how we can use cross product to determine the value of unknown variables. So over here for the topic objective, we're going to be put by the end of this lesson, I will understand that the cross products of a proportion are equal. So if they are not proportions, if the two ratios, if the two ratios are not proportional, that means that they're not equal, then their cross products will also not be equal. So the proportions it has to be a proportion. The ratios have to be equal to one another for their cross products to be equal to one another. The essential question: how do you solve for the value of an unknown variable in a proportion? How do you solve for the value of an unknown variable in a proportion? So cross products, if you need a little bit of reminder, is that in a proportion, A is to B is equal to C is to D. The products of A and D and B or C are called cross products. The way you can remember this is they form a cross, as you can see that I just formed, and the product means that to multiply. So the cross product is the multiplication answer of the values across from each other. So they've got some examples here for us. In this example of 2/3 is equal to 4/6, you can see that 3 times 4 is going to equal 12. And the other cross product, 2 times 6, is also equal to 12. And we know that 2/3 is equal to 4/6 because we understand that 4/6 simplifies to 2/3. And so if those are proportional, meaning that they're equal to one another, then their cross products will also be equal to one another, like we have here 12 is equal to 12, when we multiply the numbers across from each other. In algebraic terms, just so if you're wondering, what does this mean, algebraic terms over here? What that's saying is just the same thing, except for it's using variables to represent that this could be any numbers that we could want to put in there as long as the relationship is proportional, or in other words, as long as it's equal to one another. And then it's also important to note that B cannot equal 0 and D cannot equal 0 because we've talked about if you have 0 on the bottom of a ratio, then it's undefined. And so that would not even give us a value to be able to compare. Okay, so a question that we can put here is, will the cross products of two ratios be equal if the ratios are not the same? Fraction in simplest form. I'm going to write that down. So will the cross products of two ratios be equal if the ratios are not the same? Fraction in simplest form. So if they don't simplify to the same fraction, are their cross products going to be equal? Well, we just talked about how if the ratios are not proportional, then their cross products are not going to be equal. They need to be the same fraction in simplest form in order for the cross product to be equal to one another, just as we saw here with 2/3 and 4/6. But if we had a different example, something that we would recognize as different, like 3/4 and 1/2, you can see that 4 times 1 would be 4, and then 3 times 2 would be 6. And so we would not have we would not have a proportional relationship and their cross products would not be equal. So that's even another method of checking to see if two ratios are proportional to one another. Okay, so let's move on from this and let's try an example. So we're going to set up two rates here. You swim your first 4 laps in 2.4 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? So we can compare these in two ways. We can compare their unit rates. So we got method 1 over here, meaning that we can set up the ratio of, or the rate of 2.4 minutes takes us to complete 4 laps. So that means that it takes us 0.6 minutes to complete 1 lap. That's our unit rate. So this is our rate, and then this is our unit rate. And then we can compare the other unit rate also. We got that 12 minutes that it took us to do the 16 laps in the second round, and which that unit rate will simplify into taking us 0.75 minutes to complete 1 lap. And as you can see, the unit rates are not equivalent to one another, meaning they're not the same. And if they don't simplify to the same fraction, therefore they don't have the same value, and we would say they are not proportional. So the values are not proportional. And then another way that we could check is what we just talked about a little bit when we were writing out the question, is we could use a second method of setting the ratios up to one another. It took us 2.4 minutes to complete 4 laps in the first round, and then 12 minutes to complete 16 laps in the second round. And once we set up those ratios and set them equal to one another, if their cross products are equal to one another, then that means that they're proportional and the values of them are also equal to one another. So if we multiply the cross products, so 2.4 times 16 and then 4 times 12, then you can see that we do not get equal value. That's why there's a little slash through that equal sign. And so we would say that they are not proportional, as we already determined in that last method. But now we can see that utilizing cross products also helps us to determine whether they are going to be proportional or not. So because they're not equal, we say that they are not proportional. Okay, you've got one on your own question. We can go ahead and knock that out together. Just go ahead and watch the next video in order for us to knock that out together.